Hi folks, here we are for the second half of chapter 5, the integumentary system. We're going to begin on page 168. And so you look on page 168, module 5.3, and it talks about the dermis. You remember the epidermis is above the dermis. Got a nice couple of pictures here on 168 and 169. 169 shows the epidermis, that upper layer, and then you have over on the left side of figure 5.5 the dermis. Those two areas we're going to talk about, papillary layer and reticular layer, compose the dermis. So first of all, when you think about the dermis, look down at the bottom. You see it's using those terms that you're having to learn in the lab, deep, which means deeper into the body. You find a highly vascular dermis. Vascular, of course, means that there are blood vessels there, arteries and veins and capillaries. And so you see it says that in terms of functions, the dermis houses the blood supply, which is going to help the epidermis to some degree. Remember, we're looking at dead cells. So some cells out there on the outside don't get as much oxygen. And we'll mention that again in a few minutes. As you look at the next column, you see it says contains sensory receptors. So we know if something's pushing on our skin, whether it's a breeze or whether it's a handshake and you feel somebody squeeze. And you see also anchors the epidermis. Remember how we talked about the collagen fibers that are in the dermis attached to the epidermis. So that's important to hold the skin in place. Now, as you finish that little paragraph that talked about the functions of the dermis, last two sentences, two layers of the dermis are not simply layers of cells like we talked about in terms of the epithelium of the epidermis, but rather two different types of connective tissues. So as you look below it, you see papillary layer. This is where you want to look seriously at it. You see, it talks about it starts with that thin papillary layer, which is about 20% of the dermis. The other 80% is going to be the reticular layer. So you notice it says that the papillary layer is composed of loose connective tissue, mentions the collagen fibers, the elastic fibers, and the reticular fibers and so forth. Now, notice, come on down, it says within the papillary layer are the usual cells that you would find in there, fibroblasts and phagocytes. But look what it says about at the dermis-epidermis junction. Special collagen fibers. This is what I was just talking about a second or two ago. I thought I had covered it a little bit, but maybe I hadn't. But notice the fibers extend from the dermis up to the membrane, the basement membrane that the cells sit on. And so it anchors the epidermis to the dermis. Notice repetitive trauma, such as rubbing from a pair of ill-fitting shoes. Have you ever had blisters caused from incorrectly sized shoes? Or maybe some of you have worked with your hands. I've worked with my hands. Back when I was a kid, had to do things, and I might be using some sort of tool that's got a handle, and I'm doing various things, and I would get places that would get hot because the wood handle was rubbing against it. And that was pulling on the skin, even though it had the stratum lucida been there. But look what happens. Rubbing from an ill-fitting shoes or the handles that we sometimes have to work with can disrupt the collagen fibers, separate the dermis from the dermis, and fluid goes into that area and fills it, and we have a blister. That's how blisters come to be. Got some structure rubbing, and you end up getting it red, and it gets hot and hurts after a while. and you have actually damaged the collagen fibers. So literally your skin, which we call the epidermis most of the time, has come apart from the dermis. And now you got a fluid in there, a little fluid collection in there, and that is what we call a blister. Now, looking at the next page, 169, the surface area of the papillary layer where it contacts the epidermis is folded into little undulations or little projections called dermal papilla. Papillae is the plural, dermal papilla would be one of them. Now notice, you see the italicized word, it says the dermal papillae house tiny blood vessels called capillaries. Look at the picture, and you see the blood vessels in the fat. We all have fat under here. You want to have some fat. It can keep you warm. It can also cushion blows and so forth. So you don't want to get like Twiggy, where you just don't have any fat under your skin. That is unhealthy. What does that mean? Homeostasis, the right amount of fat in the right places. Sometimes it doesn't always work out to be in the right places, does it? But anyway, you've got these capillaries up there at the tip. You see, if you look, it says papillary layer, and you can come over to the right and you see dermal papillae, and then you see the little capillaries in there. So the capillaries are blood vessels. Now you may know this from another course, or you maybe learned it back in 110 or whatever, but it's a vessel, but it's a vessel that's composed of single cells. The wall of the blood vessel, the capillary, is a single cell thickness. That means things can move in and out of the capillary very easily. Diffusion can take place. For instance, oxygen can diffuse from the blood out of the capillary, goes into the dermis, and then eventually gets up to the stratum basum and the stratum spinosum and so forth, and granulosum. But eventually it gets used up by those 3 or 4 layers, 2 or 3 layers, and the layer on top, which we call the stratum corneum, doesn't get any oxygen. The same thing is true in terms of nutrition. Glucose can move out of the bloodstream and it can make its way into several layers of cells, but eventually it gives out. It's used up by other cells, and the top layer, the stratum corneum, don't get the oxygen. They do not get the nutrients like glucose, and so they die. So I think we might have mentioned that before. You look at me, you're looking at dead skin. And when I'm looking at you, it's dead skin. And we fluff that stuff off. We shake it off all day long. It's a way to reduce the bacterial concentration on our skin. We're always going to have bacteria on our skin. But as long as we keep it in check, it's okay. We're actually finding out, when you take microbiology, they are finding out there are microbes that do a lot of good things for us. Microbiology is a wonderful course. Just amazing how we can use these little guys to actually help us. We can actually use some bacteria to fight another bacteria to get rid of an infection. Anyway, you know about now the dermal papillae. You want to keep those in mind because we're going to come back to them a little bit. And then you see it says in the second paragraph, speaks about the Meissner's corpuscles, and they respond to light touch. It helps us distinguish the shape and the texture of different objects. So you think about something crawling on your skin, or you rub your fingers across there, you are picking up information. It goes up here, and you try to relate it to what have I felt that tells me what I'm looking at, even when my eyes are closed. So it helps us identify things. Light touch, like a little bug crawling across your body. I was in bed one night a couple of years ago, and I felt something down there on my calf, and looked up down there, and doggone if it wasn't a tick. Somehow I picked a tick up in the yard. That little guy just working his way up, try and bite and chew through me and get some blood, and that's a great way to get Rocky Mountain spotted fever or Lyme disease. So you want to, if you like to go in the woods, make sure you check yourself over all over. They like your rear end too, the inferior, the lower parts of the body, under here, under your breast and all that. And they'll get in your hair up here. And if some of you got a lot of good hair, it's very difficult to find them. Easy up here for me, but for you guys that got a full head of hair, it can hide there. So, but you can feel them if you're still and you focus on some things. You can usually feel them. Now let's leave that papillary layer. We're in the dermis still, but we're going to be talking about the reticular layer. So you come down to where you see reticular layer, and you see it says it's composed primarily of dense, irregular connective tissue. Look over on the second column. You know, that means that the fibers are not arranged nice and parallel as they would be in a tendon or a ligament. So you look at the second column and you look at the second paragraph. It says we find elastic tissues in the reticular layer of the dermis. And those, of course, elastic would help your tissue be springy. It would come back to its original shape if it was stretched a bit. But come down to the middle of the paragraph, not the middle, but let's see, third line down. Note that if stretching is extreme, then when we say extreme, for the ladies, it seems to mean more like when you're pregnant and your belly is distended for a period of time, then sometimes you tear those tissues and you get, if you come down about 4 lines, you'll see the italicized word striae. Striae. Little stretch marks, most people call them. The same thing would happen with your breasts. As they fill with milk and they stay large like that, it's possible that you get some stretch marks on your breasts. So wherever there's some stretching, and that might even happen if you get overweight, that can stretch that tissue. And then if you lose weight, you still have the stretch marks. So we can exceed the capability of the elastic fibers. I also want you to notice as you come down in that same paragraph, after striae, come down to the sentence that says, right under striae, the reticular layer also contains a ground substance rich in proteoglycans. That's a protein and a carbohydrate. Now, the reason those combinations are in that reticular area is they pull water, osmosis, out of the capillaries and into the dermis, and then up into the stratum basal, stratum spinosum, stratum granulosum, and so forth. We all need water. And those proteins help keep our skin full, as it were, instead of looking like some shrunken bag or whatever. So it's important to have the right diet, have those proteoglycans present in the layer of the reticular dermis. And you come down, last thing we want to mention about this is the laminated or Pacinian corpuscle. It's another, excuse me, it's another type of receptor. And you see as the last sentence, that is associated with experiencing deep pressure. If you look at figure 5.1, let's see here, we're on 5.5 up top. But if you look at 5.1, yeah, you can see one of these guys. 161, page 161, figure 5.1, and just look at your labeling and you'll see lamellated corpuscle, or you can call it a Pacinian corpuscle. But you see how far down it is? So that means that, that means that it's going to take firmer pressure before you're aware of maybe pain. So those guys might kick in whenever something starts squeezing too much and you can feel the pain. Now we're going to leave the dermis for just a second. In that heading, we're going to skin markings. We're still going to be dealing with the dermal papillae. But look at the last three lines, interactions between the dermis and the epidermis are visible as small lines in the epidermis. They call them skin markings. And the most obvious ones, you look over on the next page, page 170, and you see it says on the palmar surfaces of the hands and fingers, the same thing on the soles of the feet and the toes. It says here the dermal papillae are extremely prominent. Thick collagen fibers arrange them into dermal ridges. And it says this structure indents the overlying epidermis, so you produce epidermal ridges. Now, if you look real closely, and you could do this with a magnifying glass, look at your fingertips, and you see all these ridges. Those ridges are meant to give us traction, like tires on our car. You don't want to wear those tires down too much. You'd be sliding around, right? You got some little wear bars in there, so you want to make sure that your wear bars are down deep. You got some good tread to help you stay on the road in the water in a rainstorm. Not only do they help us grip things, but they also identify us, because each one of us has markings here and on our feet that are peculiar to us. So it helps people identify criminals. So those are what we call fingerprints. So those epidermal ridges not only help us with traction, but they also identify us. Now, I want you to do this for me. I want you to look on page 171, and you see where it says skin wrinkles. Some of you may know about this, but you can read about wrinkles. Everybody gets wrinkles if they live long enough. But you know, there are a lot of people that want to have their face look very young, and they got stuff they'll rub on here, and they show you 5 minutes from now, oh, you look completely different. And of course, it goes on for an hour or two, and then you got to go back and do it again. So you don't ever get rid of it. But here's another way that they try to do that, is you come into that first column on page 171, and you see skin wrinkles, come down to what you see as Botox. That is botulism toxin, or some people will call it botulinal toxin. It's the most potent biological toxin on the face of the earth. So they inject you with that, not enough to kill you, because they want you to come back and pay some more money. But it does make things relax up here around your eyes. And sometimes they even use it to ward off headaches, migraine headaches. And they also have been using it to help with, it seems to be the ladies most of all, at least that's the one they show on the TV, with an overactive bladder. It helps the bladder relax a little bit. And so they don't feel that pressure, and they don't have to stop every 2 blocks as they go through a city or whatever and let some urine out. Now we're going to look over on 171, module 5.4, skin pigmentation. And as you look at the first paragraph and you read through it, you'll see there are 3 pigments we want to mention. Melanin, they're all in italics here, not in bold print, but you have to just look a little bit for them. Carotene and hemoglobin. So first, let's look at melanin. Primary skin pigment, down at the bottom, in bold print, produced by cells they call melanocytes. Those are the ones that produce the melanin. And you see melanin can range from orange, red to black. Now notice in the next couple of sentences, melanin is made up of 2 amino acids. The amino acids are called tyrosine. So 2 of them are brought together in a chemical reaction. What chemical reaction occurs to cause those 2 to hook onto each other? There's an enzyme that helps. Remember, I've told you that you see tyrosinase. ASE on the end tells you you have an enzyme, which means you've got a protein that carries out a particular activity. Tyrosinase is not going to help you digest your bread when you eat a hamburger. It's not going to help you digest your barbecue when you go out to Schuler's Barbecue or the schoolhouse or wherever. It's not going to do that. It's made specifically to join two molecules of tyrosine. So what kind of chemical activity is that? See, this is in chapter 2, and it's coming back in chapter 5. That's why I tell you, read over your notes. Keep those things flowing in your head, because we keep building. Now, as you look on page 172, let's see, we need to do something here. Back in on 171, as you look at the last paragraph, you see it says melanocyte has numerous arms. You look over here on page 172, figure 5.8, and you see the little arms going out. And that cell is producing melanin. It's called a melanocyte. Looks like a little octopus with all these fingers out. But you see the little bodies they call melanosomes? That's where the melanin is being produced. And notice the arrows. They move out the little finger-like structures. It looks like the little finger-like structures sort of penetrate. Sometimes that's what they say happens. It penetrates the next layer up, which would be the stratum granulosum. We got stratum spinosum and then granulosum. And the little packets, if you want to say, or vesicles, probably kind of like a phospholipid membrane, empty little cavity, but it's got melanin in it. And melanin is placed in those cells in the granular layer, and it gets between the sun and the nucleus of each of the cells. So it's, if you can picture this as a cell, here's your nucleus, the melanin is released up here to protect the nucleus from ultraviolet radiation. The doctor says go out and 10 minutes, every 3 days, every other third day or something like that. Well, the thought is homeostasis. We need a certain amount of ultraviolet radiation to help us make vitamin D, but this is a substance that helps protect the genetic material. If we didn't have that, the ultraviolet radiation would alter the DNA and we would have some problems, possibly skin cancer. So that's one of the functions of melanin. As you come down on page 172, first column, and you come to this third paragraph, it says one of the functions of melanin is to protect DNA of keratinocytes, so we don't get any sort of problems there. Again, it's the balance, It's so hard for us to be balanced, whether it's eating and drinking or whatever, or sleeping. Sometimes, boy, some people just want to sleep. But homeostasis. Now, here's another function. Look at the second column. You see, second function of melanin is to decrease the synthesis of vitamin D. You say, don't we want to make that stuff? Yeah, that's true, but we don't want to make too much of it. Again, homeostasis. Boy, this thing just is going to go through all of the 2 semesters. It's the same thing in microbiology. Homeostasis with microbes that live in us and on us and so forth. Look at the top of page 173. And you see up there, it says the answer is that vitamin D levels must be kept within a specific range. An excess amount leads to calcium imbalance. Now, calcium is needed for muscle contraction. It's needed for nerve impulses. It's needed for bone development. But our tendency to think, well, I got to get a lot of that. That's great. Well, you want just the right amount. Life is a balancing act. You got to work. You got to sleep. Okay? The same thing is true, keeping your body in good shape. And notice, it can also cause kidney failure when you have too much of that. Got to have just the right amount. Now, let's see, there was something else I wanted to have you look at. As you look at the third paragraph on page 173, you see it says, as you have probably noticed, skin pigment isn't evenly distributed. You don't find a lot of pigment between your legs, underneath your armpits and stuff. It's on this outer surface and your face, up in terms of being exposed to the sun. But we just don't get that much sun that way. So that's why you have lighter areas of your body. Now, let's see. There was one other thing I wanted to mention. What did I see there? Well, I don't see it right now, and I've just missed it evidently, but all of us have about the same number of melanocytes. It's the type of melanin that we produce or how much we produce. So if you don't produce any, you're an albino. And if you produce loads and loads of it, you have very dark skin, very black skin. And then there's all in between. But that's all genetics. So our first two parents, we don't know what color they were. But it got all this variation, Let's come down to a couple of these other pigments. You see carotene and hemoglobin. Carotene, Carotene. You can get it in your diet and vegetables. We need our vegetables. I know a lot of people are just meat eaters, but we need our vegetables too. And carotene is a precursor of vitamin A. We need to ingest some carotene. Carotene also enhances ultraviolet protection, and it's also an antioxidant. Some of you may be hearing about this term, antioxidants, like when they talk about fruit juices, pomegranate and grape juice and things like that, or even wine. The doctor says the wine's got various substances, and they'll label them generally as antioxidants, which actually help your cardiovascular system. He asked me when I was, I don't know, years ago, you have a problem with drinking wine? I said, no, not really. He said, why don't you drink about 4 ounces each night of red wine? Well, I can do that. He didn't say 40 ounces, okay? He said 4. So again, there's that homeostasis that we have to just build up in our minds. So carotene is a benefit. You can get it through wines, egg yolks and vegetables. Hemoglobin, that's the pigment that we have in our red blood cell that carries oxygen throughout the body. So whenever, as you look at the last sentence there, the interaction of hemoglobin with oxygen gives blood its characteristic red color. It's that hemoglobin that's hooked up with oxygen and that has a bright red. See this spot up here? I whanged my head on a gate on a Nissan Pathfinder. My grandson and I were working on a little problem, and I'm 6'1", so they never have those things high enough to where I can walk under. So I hit it good that day, and it was a nice red blood that came out. So I know I'm getting plenty of oxygen to my bloodstream. It was not dull. It was very bright red. Now, speaking of red, as you look at 173, you've got this skin color as a diagnostic tool. So there are some colors that you want to be familiar with. Erythema, you see the bold print term, means it's red. Excuse me. We might turn red when we get embarrassed. Our blood vessels dilate. We get more blood out there. You can feel the heat coming off your face. We get embarrassed. Pallor, you can read about that. It means that people are getting very light colored, and then the color is going away from them. They say their skin is in a stage of being pallor. So very lightly pigmented. Then you come down to cyanosis, where there's a little bit of a bluish color, and that means they're not getting as much oxygen as they should for whatever reason. So let's look over on page 174. Module 5.5, accessory structures, hair, nails, and glands. Just a little bit about hair. Hair has functions of protecting us to some degree. You got hair in your nose, it can help filter things out. These eyebrows can help, and so can eyelashes. If you got enough hair on your head, it protects your head from maybe even a blow and from ultraviolet radiation. But my dermatologist said, if you go out for 15 minutes or more, put on a hat, because I don't have any protection up here. So hair has its place. You want to take good care of it. And notice in the second column on 174, second paragraph, hair is derived from the epidermis, and so it consists of squamous, keratinized epithelial cells. It's a different conformation, though, isn't it? It's not yours. So it's really an extension of skin, epithelium. As you look on the second column and you see the structure, I want you to know the shaft. That's a part that we see on people. The root goes down into the skin, and the root actually goes into a hair follicle. Now, you can get a follicle infection, and they call it folliculitis. So you'll see the hair, and you'll see a little yellow cap maybe right around the base of the hair. That means you got pus stuck in that hair follicle. And one other thing about the hair, you come on down, you see arrector pili, and tiny little muscles that are attached to our hairs under the skin. When we get scared to death, those little muscles will contract, our hair will stand up. The same thing will occur when we're really cold. They'll contract and make this hair stand up. And so, anyway, that's what I want you to know about hair. They call it goosebumps, chicken skin. Okay, let's see. You can look at on page 175, second column, come down 1, 2, 3, fourth paragraph, the last paragraph. Hair grows most rapidly from puberty to the 5th decade. After that, it slows down. And we have on the next page the nails. A little bit more hair here. First line up on 176, you see alopecia. That's what I got. Hair's all falling out. Started falling out when I was about 27, 28 years of age. Lanugo, Lanugo, that's the fine hair that is on a newborn. You may hear people talk about lanugo. So now you know what it is. You know what your nails are. Everybody knows about fingernails. Some of you ladies got some glued on stuff. Just make sure that person does a good job, because I remember when they started wearing false nails and they didn't clean it like they should, and they got a yeast in there, and that yeast ruined the real nail. They like the keratin that's in our skin, those molds and yeast like that, and they like the keratin that is in the nails. So make sure they do it well, because you're trapping stuff in there if you don't clean it out properly. So haven't seen too much problems with it lately, but I remember what it did. National Geographic had a special on it. It was a mess. Come on over to 177. I got just a couple more things. I can actually get you to just read these. But you see on 177, you see glands. And you got two kinds of glands. You got sweat glands, sudoriferous, and sebaceous glands. Sudoriferous produce sweat. Sebaceous glands produce an oil. So let's look at them. Sweat glands. Over on 177, second column, there are 4 kinds. We're just going to do 2. Eccrine sweat glands. These are the ones that we have under our armpits and on our forehead and so forth. They're all over the place for the most part. And you come to the second paragraph, you see sweat's 99% water. You probably know that. but it's also got salt, potassium, and sodium, potassium, and fluoride in there. You know that if you played soccer or softball and you lick your lip, it's sweaty, isn't it? I mean, it's salty, isn't it? And of course, the sweat is there to cool you off. Now in South Carolina, that doesn't work real well in the summer because the humidity is so high that the water from the sweat cannot evaporate. But once the humidity comes down, it can be 90 degrees outside and you feel warm, but your sweat is evaporating, and that's what cools you off. If you can't have that sweat evaporate, you're just going to be hot and wet. That's all it is. It's going to be kind of a miserable type of thing. So you know about sweat now, and you know about sweat glands. Those are eccrine glands. That's a type of sweat gland. One more type of sweat gland I want you to know is over on page 178, called a ceruminous gland. So you can read about that. Cerumen is the fancy word for wax. Okay. Some people produce too much of it. I know in the military, I dug it out of people's ears. And then they can hear, but you have to do it usually with a little peroxide going down there to break it up, soften it up. Use a little baby syringe, not a syringe, little squeeze bottle. It's got that little nozzle on it, and you can clean gently the stuff out, and it's not a big problem. It just takes a little bit of time. Then the last type of gland is called a sebaceous. Well, you can read about ceruminous glands. That gland, the cerumen, is necessary. It's important. You just read it and you'll see it. Sebaceous glands. As you read in sebaceous glands on 178, coming down the first column, you see it says the ducts converge to form a central duct that empties into a hair follicle. Excuse me. And you come down to the next paragraph, they produce sebum. It's a type of oil. Sebaceous glands are holocrine secretion. You remember how that is? A cell just bursts. And then sebum, come on down and read it how it coats the skin and the hair, keeps it supple, and also keeps us from losing water through our skin. It is hydrophobic, so it tends to keep water in as well as somewhat out. Again, a balancing act there. So that's about all I want to read about sebaceous glands. The last thing is on page 179. I'll get you to read these. You see first degree burns, second degree burns, and third degree burns. And you want to be able to describe a first degree burn, second degree burn, and a third degree burn. Rule of nines on page 179. You don't have to go memorize that. Just know that it's a method that they use to send information to a hospital, telling the hospital, we have a burn patient and 35% of their body is burned, 15% of their body is burned, or whatever. The hospital wants to prepare to give that person fluid, because when you have a burn, second, third degree burns, you're going to lose fluids, and that can mean the difference between life and death. So don't go memorize all these things, but just know get a definition for what the rule of nines is. Why do we use it? What is it, and why do we use it? So I'll let you do that, all right? Get you to think about it a little bit. Last thing is skin cancer, and you can read about the types of skin cancers that we want you to know: basal cell, squamous cell carcinoma, and malignant melanoma. So you want to be able to tell me what cells have become cancerous, which ones tend to spread, okay, and identify them. Got some nice pictures there. Got a friend who happened to be rubbing his body in the shower, and he thought, where is that? What is that coming from? And doggone if he didn't have malignant melanoma. Had to go to Charleston, they cut it out and so forth, and he's okay. But you can see how irregular that malignant melanoma is. as compared to the other two. Now, basal cell carcinoma is usually not a problem. They can just take it out surgically. So anyway, you want to be able to differentiate those three types visually and verbally. All right, I'm going to close it out. Here we are at 40 minutes, and that's good. All right, I'll be in touch with you. Have a good afternoon.